Good morning and happy Math Monday. Hope everyone's having a relaxing 3-day weekend after all those APs. Anyway, so as you know, this work won't be due till the 1st of June, but any late work is due this Friday, the 29th. So let me go ahead. We're going to continue with the conic section. So we're moving, like we did with the circle, we are not going to have the center be the origin. So I'm going to do a short little video on hyperbolas and ellipses first, and then I'll go on and do a review of parabolas, which you've already done. We did it first semester, so it'll be a nice little review. And then we'll talk about our final project. Okay, so I'm going to move to the document camera, and I want you to write down the objective for this lesson. Central conics. You will be able to find an equation of a conic section with center not at the origin and identify a conic as an ellipse or hyperbola. So this is really kind of things that you've been used to. It's nice and easy. Let's have a look at ellipses first, and then I'll move it to the hyperbolas. Here, the center is going to be H and K, are X and Y. So for an ellipse, instead of just being X squared over A squared plus Y squared over B squared, now we have the minus H and the minus K. And it's an ellipse, it's equal to 1, and it has a positive. Now, because we've moved it off the origin, then the foci are not just going to be from the origin and X and Y. Here, you would have H minus C and K, and H plus C and K. So we know that's from the center. C is from the center to the foci. So C squared is equal to A squared minus B squared is what we use if we've got to find A or B or C for that matter. So this is where we have the horizontal major axis. And we can see with ellipses, if it's horizontal, then A squared, which is the bigger number, is under the X, B squared, the smaller number, under the Y. And then this changes when we look at the vertical axis. So here, for the vertical axis, we are going to have B squared under the X and A squared under the Y. Again, you can see because the center isn't the origin, you've got H and you've got K minus C and H and K plus C. Again, it's an ellipse, so we have the minus sign in our C squared is equal to A squared minus B squared. So this is for the ellipse, the equations for the ellipse that have a center that is not at the origin. Now let's have a look at the hyperbola. We know it's a hyperbola because it's got the negative there. It's equal to 1. Now, on a hyperbola, unlike an ellipse, the A and the B do not move positions. A squared is here, B squared is here. Doesn't matter if this is a bigger number or smaller number. What really matters is if there's a negative near the Y squared, the X squared, the X, the horizontal major axis, is where the branches are going to be. That's because that's positive there. And for here, you have to look at the foci at H minus C and K, H plus C and K, and C squared is equal to A squared plus B squared. So that's for the horizontal major axis. Let's move it up to the vertical one. Again, notice a squared, b squared do not change positions, but because this is the vertical, the branches are on the y-axis, okay, because the negative is on the horizontal. The foci are at h and k minus c and h, k plus c. Again, c squared is equal to a squared plus b squared. Okay, so let's do some examples together. I'm not going to do too many, but let's see how we get our answers. So let's have a look at this first example. Right, so we're going to find an equation. We've been given that it's an ellipse, so there's certain things that we know. Here, the information we're given is where the foci are and what the sum of the focal radii are. So straight away, you know what A is, because we know that 2A is equal to 14, therefore A is equal to 7, right? So here we have that little bit of information. Now we're going to see where the foci are, and wherever the foci are is what determines what our equation is. So if I quickly drew, sorry, that's a x and y axis, and I said to myself at -3, 4, which is here, -3, and that's 4, right? And then at 9, 4, so 9, 4 on our coordinate plane, those two are where the foci are. And if you know that the foci are there, and we know it's an ellipse, we know that it's going to have that horizontal axis, right? The major axis is going to be horizontal. The first thing we need to do is find the center. So what's the distance from here to here? And then find where the midpoint is. And if I look to see where the midpoint is, it's going to be where x is 3 and y is 4. And that's the center. So then we can put in that information into our equation. So let's have a look to see. So what have we got? We've got 3 and 4. X is 3, so the 3 goes here. Y is 4, goes there. And so do we know what a squared is? Well, we know a is going to be our bigger number. And so because of the horizontal, then it's going to go where the x-axis is. So 7 squared, 49. And all we have to do now is we have to find out what b squared is. So fairly easy. We've worked out the center. We know what a is. So we're going to use our c squared is equal to a squared minus b squared. So c squared, we have to work out the distance from the foci to the center. And the distance from the foci to the center is 6, because this is 12. So c is equal to 6. So once I've got that, I've got 36 is equal to 49 minus b squared. All I need to know what b squared is, so make the b positive. 49 minus 36, b squared is equal to 13, right? So we can now put 13 into the b squared there. Therefore, this ellipse is x minus 3 squared over 49 plus y minus 4 squared over 13 is equal to 1. So there we have our equation with the information that we've been given. Okay, so let's have a look at example 2 to do with a hyperbola. Okay, once you've got that, then you can say to yourself, what have we here? We have a hyperbola. Again, we've got the foci, and we've got the difference of focal radii. Okay, so copy that down. Once you've got it copied down, then let's have a look what we know. We definitely know that 2a is equal to 8, and therefore a is equal to 4. So that's nice and easy. Now, if we're looking to see, once we have that, we're looking to see, sorry, just get that back in there. Now, you don't have to draw a coordinate plane, okay? It's just the fact that I want to show you visually where those points are for the foci so that you know. So let's have a look. We've got -3, -2. So if I've got -3, -2 here, that's one of my foci that I've been given. And then the other one is -3, 8. So here's the 8, -3, 8. That's my other foci. So we know here, wherever the foci are wherever the branches. So the foci are within the branches of this hyperbola. So the branches open this and this way. Okay, so we've got a lot of information already. Now we've got to find the center. And the center is going to be the distance from here to here. And if I look to see where that is, then I know that the distance from here to here is 10 spaces. So 5 is going to be -3, 3. So that point there. Okay, so distance from here to here is 5. So C is equal to 5. So we're getting lots of little bits of information. Now, once I've got the center, so here I can write down that the center is going to be -3 and 3. Right, so then you say to yourself, if the branches open up and down here, then y squared is first. It's positive. So here, y if I've got y squared here minus, and then I've got x squared here equal to 1. And remember, a and b never swap places. So these are minuses. This is minus k, so that's going to be the 3 because it's the y. And here, x, negative 3, that will make that a positive 3. And I know that a, which is always under this first parenthesis, is 4. 4 squared is going to be 16. And so all I have to do here is I have to find b squared. Again, you're going to have your c squared is equal to a squared plus b squared. So c squared, which would be 5 squared, is 25, is equal to a squared, which is 16, plus b squared. Move the 16 to the other side. B squared, 25, minus 16 gives me 9. So that 9 would go under there. So now we have y minus 3 squared over 16 minus x plus 3 squared over 9 is equal to 1. And therefore we have our equation. Okay. So a little bit of a review in the sense that of what we're looking at, but also trying to remember our H and K's that we've used before and how we've used them. Okay, let's go on to example 3. So, example 3, we're going to identify the conic, find its center and foci, then we're going to draw the graph. So, a little bit of algebra and then graphing, not too bad. Okay, so same as the circle, we're going to take our A and we're going to then complete the square on the x's, complete the squares on the y's. But this time, some of them are going to have a coefficient, leading coefficient, greater than 1. So let's go with the first one. And I'm going to do completing the square for both of them, and then we'll go on to the graphing for both of them. I think that will kind of give you an idea what you're graphing. So let's start with A. So put your x's together. X squared minus 2x, and then you leave a little gap, minus 4y squared minus 16y is equal to 11. So the constant term there is negative 11. And remember, the constant term needs to be on the other side of the equal sign. So have I got a leading coefficient of 1? Yes. I'm going to take my negative 2, divide it by 2, it's equal to negative 1. I'm going to square it, and then I'm going to add 1 to both sides. So that's fairly easy on that side. Now, here I've got a negative 4. So I'm going to factor out the negative 4 first. So I'm left with y squared. If I factored out a negative, this makes this positive 4y is equal to 12 here. Okay, so now I'm going to take 4, divide it by 2, that's equal to 2, 2 squared is equal to 4. So that's 4. Now, one thing you have to remember here is that if you factored something out, you then have to make sure that you multiply this with this. So now you have negative 16. Okay. So look over it again, make sure you understand. Here we have x minus 1 squared. Now we can't forget that minus 4, so whatever you factored out has to go there. And then we have our y plus 2 squared is equal to 12 minus 16, easy peasy, negative 4. And obviously it doesn't look like anything at the moment. So you have to divide everything by negative 4. Okay, so if we've divided everything by negative 4, negative and a positive will give me a negative. So you can tell already that this is going to give me a negative. This here is going to be minus x minus 1 squared over 4. This is going to give me equal to 1, which all ellipses and hyperbolas have to equal 1. Now here, a negative and a negative is going to give me a positive. That's going to be 1, that's going to be 1. So here I have y plus 2 squared. Now if I left it like that, that would be fine. So sometimes when you're seeing this, you can have nothing under it, then you assume it's a 1, or you can do a 1 like that. Okay, got it? So here is our equation, and we are then going to say, it says identify the conic, so you must put what it is. So this is going to be my hyperbola. Right, hyperbola. So here we've completed the square, we've found that it's a hyperbola. So we're going to also draw the hyperbola in a second. So that was 3a. Let's have a look at 3b, and then we'll get on to doing the graphs. Looks a little bit more complicated, but really isn't. So here, 3b is our 9x squared, and then we're going to put plus 36x, then leave a gap. And then we're going to find our y squared, which is plus 25y squared minus 150y, leave a gap, is equal to, take your 36 and put it on the other side. So negative 36. Right? So once we've got that, we cannot have, as I said before, anything larger than 1 as our leading coefficient. So obviously we're going to factor out a 9. So whatever is in front of the x, you factor out, even if that gives you a fraction. So 9x squared plus 4x. So here we've got our 4, we divide it by 2 is equal to 2, then we square it and we end up with 4. So that's going to be plus 4 here. It's not just going to be plus 4 here. You're going to take your 4 and you're going to multiply it with the 9. So that's going to be plus 36. Okay, so here we're going to have 9 and we're going to have x plus 2 squared. Now we're going to factor out 25 so that y squared has a leading coefficient of 1. So that will give us y squared minus 6y equals, and that would be 0 there. So we're going to take our negative 6, divide it by 2, which gives us negative 3. Negative 3 squared is positive 9. And now you're going to multiply your 9 with 25. And so you have 0 there. 9 times 25 is 225. Okay, so now I've got plus 25 here and multiplied by quantity y minus 3 squared. And that is all equal to 225. Remember, this has got to equal 1. So we've got to divide everything by 225. Oops, my red pen isn't so red anymore. Hopefully you can see that. Okay, so once we've got that, we've got the 1 that we need. And this is 1 and 25. So now our equation is x plus 2 squared over 25 plus, that's 1, and that's going to be 9. We have y minus 3 squared over 9 is equal to 1. So here's the equation that we're going to graph, and that equation here is an ellipse. So we have an ellipse here, and we're going to graph it in a minute. Its center is not around the origin, so we can already see that the center of this is going to be negative 2, 3. That's the center. And like the one that we just finished for the hyperbola, which is what we're going to graph first, is, did we know what the center here was? Yes, the center here is going to be, so for x, it's going to be 1, and for y, negative 2. Oh, right, so good job on that. Let's go to graphing this. Now, let's graph the hyperbola first. So we've got our x and y coordinates. We are going to need to have our ruler. We're going to find the center first. So let's go with that. So center is 1, negative 2. So when x is 1, y is negative 2. So you put your center in first. Now, on our, under the y, we had quantity y plus 2 squared over 1. So that means, what's the square root of 1, which is 1? We go up 1 from the center and down 1 from the center. And then we look what the x is. And that's going to be 4. Square root of 4 is 2. So 1, 2, 1, 2. And you can see that we're going to draw our little box around here. And that's going to help us with our asymptotes. Sorry, I'm going to turn it on its side. Yours is obviously going to be much better than mine, as I always keep saying, because you've got wonderful graph paper. But this just gives you an idea. This makes graphing the hyperbola so much easier. So now that we've got our rectangle, the next thing we're going to do is we're going to draw in our asymptotes. And here, I'm going to do a dash line. So from the center to this corner here, from the center to this corner here, center there and there. So nice big lines, and then we'll go back to see the equation. So a dash mark through the center, which will give us our positive, and then again here through the center. So have practice at this, because your project is, oops, also going to include all of these conics, central conic shape. So now we've got our asymptote lines, and we're not going to find the equation of these at the moment, but we are going to find the foci, and I'm going to just remind you what that is in a minute. So what was positive? Y squared was positive. That means that here is where the branches are. So from this vertices point, we're going to draw the branches of this hyperbola that go nearer and nearer the asymptote. And when we do the parabola, sometimes we find points, but with the hyperbola, once you've got the asymptote, then that's all you need to do for the time being. Okay, so there is our hyperbola. Now let's find the foci, and the foci here are going to be, I've got h and k minus c, and I've got h and k plus c. So do I know what c is? Absolutely. I've got a squared plus b squared equals c squared. So 1 plus 4 is equal to c squared. 5 is equal to c squared. C is equal to plus or minus rad 5. So now that makes that so much easier. The way you write down the foci then are that h is 1, and then I have k, which is negative 2 minus rad 5, which in this case would be plus, and then I have 1 minus 2 minus rad 5. So those two are your foci. And if you were having to put the foci in, what is 1, if you were putting it as an ordered pair, if I've got negative 2 plus rad 5, it would give me about a 0.2, or negative 2 minus rad 5 would be about a negative 4.2. So you can put your foci in, you know, you have to kind of convert it to decimals. But in this format, when you find the foci, then it's fine. Okay, so hopefully got your hyperbola of A and found the foci. Right, let's move on to our ellipse. So again, where's the center and how are we going to find the rest of the points? So we know what the equation is. Quantity x plus 2 squared over 25 plus y plus 9 squared over 9. So our center, we said, was -2, -9. So -2, -9 is here. And then if we're looking at the x and it goes 5, if you can see those dots there. So horizontally, 5 this way, 5 that way, and then vertically, you're going to go 3 and 3. Okay, and that gives you the shape of your ellipse, which, again, I'm sure you're going to do a better job. Right, so there's the ellipse and the equation of my ellipse from 3b. Okay, so that is the end of looking at ellipses and hyperbolas, not on the origin. And I'm going to give you your homework, which is going to be graphing. And so if we have a look at this first sheet, it's classifying and graphing conic sections given the general equation. And so we have not in standard form. You have to make sure it's in standard form. You have to classify each conic section, write its equation in standard form, sketch the graph. For the parabola, identify the vertex. For circles, identify the center and radius. For ellipses and hyperbolas, identify the center and vertices. So for parabolas, you're doing the vertex. Now, I am going to do a short little review on parabolas. So if you want to leave the parabolas until I finish the next video, which I'll also post today, let me know. Okay. So I've given you a hint that 5 is a parabola. If you look at central conics, you'll notice that for all of them except for the parabola, both variables are squared. So look at 2 and 3, 4 and 5. There's your graphs. And there's just 10 graphs to do on this one. And as I said, I'll go over the parabolas in the next video. So, but make sure you can do those. Okay, so that one's stopped the video. Let's go to number 6. Six and 7. Again, 9 is a parabola. And if you're not quite sure, then watch the next video. I'll be going over some of those as well. Let's move it up a little bit. That's 9. And the last question, 10. Okay, so those are 10 questions from the graphing part of it. And on the next video, I'll give you the rest of the homework and some of the homework sections. Okay, so hopefully that makes sense. And you've got each of those equations, not too much work on that section. And on my next video, ooh, the sun's shining. The next video, I'm going to go over parabolas. Okay, see you in a few minutes. Take care. Okay, well done on the graphing.